And we are live. Okay, the latency is still high, but we are live. So, this is continuation of the stream of yesterday. So I see the bench is not clean because I almost started doing it. Yesterday we fixed this board, or at least I tried to fix this board. Where is the part? Here is the part. So this is a USB to DMX controller. And the issue is that the USB connector got ripped away because, yeah, it is. So the USB connector got ripped away, and I wanted to fix it. Else everything works. I've tested everything works. So what I did is I put another USB connector and put some epoxy so it's a bit stable. And actually inserting the cable was fine, but when I pulled on the cable, it pulled again the USB connector. This is exactly what happened before, and the epoxy didn't help. Also, so yeah, there's a huge, again, this is why I hate micro USB, is because most of them are surface mount. Here you only have two pads, which are surface mount, plus one, so they have added even a pad on the bottom to help soldering the surface mount, so it's a bit more robust. And still, it didn't hold well enough, simply, but yeah, you will put a lot of force, particularly if you do in the events business. Then when you do lightning, you connect and disconnect very often. So this is almost the only bad design I can see from that, is that this USB connector, and it got ripped away. So what do you expect? And I've replaced it with another connector. Again, I sold it, but I only had two pads, and the pad in the middle was already ripped away. And I've added epoxy, so this was in the previous stream. It hardened, putting it, the cable was right, pulling the cable ripped everything away. And the problem is also it ripped the traces here away. So I cannot just put a small connector again. I will have to somehow connect the pins of the connector here. And this is why I have the microscope right there, because this microscope, so this is normally a dental microscope I picked up. I don't have a trinacular microscope, so I have this second camera which will show you what I mean. So if I put the board under the microscope and it is right location, now I switch to the other camera with a strong macro lens, switch camera. Here you see a lot better what I will be doing. Ideally, I would have a microscope with a trinacular, so I can have really a dedicated camera on top of it, but that's not the case. And what you can see, is here, the traces have been ripped. I've already scraped a bit of the traces, and I will connect the pin using enamel wire or coil wire to connect the pins from the micro USB here up to here. But first I need to fix this micro USB. So we know surface mount doesn't work. We need to put, like I do in all my designs, we need to use USB connector which has tabs, which will be a lot more robust. Let me get one from my SMD book with things. And when you do mechanical stuff or connectors, you want it to be very robust, and we will use something like this. You see, this is the right way to do it. 4 tabs which go through the board. Sure, it is more expensive because this is not surface mount anymore, this is through hole, so you will have to solder the 4 tabs by hand. And actually, is everything surface mount here? So yeah, all the parts are surface mount. You can see it from the back. On the back there are no leads. So this would cost a lot more because the process now has to go to a hand soldering, and that's probably also why they didn't put the connector here. And hand soldering, it's an added process and you have to pay for each point. But for mechanical designs, I think there's no alternative for mechanical connectors. And this is what we'll do here. Because we don't have the holes, we will make holes through this board so we can put the pads inside it. And because we have no traces on the back, we are fine. We can do that. We only have these pads, and I'll be happy if I can reuse these pads to solder the the connector. Else, yeah, that's another issue. Normally these, you solder these tabs on the other side, but here we don't have any ground filling I could use to solder on it. So instead of soldering, I will use epoxy glue if I cannot find any point to solder. I hope I can use these. You can see here, so because I have a huge micro lens, you don't have a big depth of field, so you don't. This is not in focus anymore. Only the board is in focus. But I will try to use these two pads to solder two of the tabs, through-hole tabs, and then on the back side, I'll probably use epoxy glue to make it a bit more stable. And the other problem is also I will make holes, but they will not be plated. So ideally they would be plated so the solder flows on the inside and also connects to the pads. We won't have that, but it still will be a lot better than just surface mount. So now we need to make the holes. Let's switch to the other camera because I will not do this on the microscope. Let's have it around here. Okay, now you have to hold tight. Yeah, something like that. Okay, approximately see what I will be doing. This is just to test. Up, up, up. Okay. Oh, making holes. Now I think 2mm drill should be fine. Let's check with the caliper. How large this hole? 1mm would be even fine. Okay. 0.7, that's 0.8, 0.7, and that's 0.9. 1. So 1 and 0.8 would be great to have these. So mini drill. I broke plenty of them, but I got new ones. Up. The teeny tiny drill. Up. Here my drills. I probably can use these ones. They are less fragile than these ones. So these are micro drills. They are very fragile. They have although we do have all the width. So this is 0.9. No, we need either 1 or 0.8. 0.8 is broken. Used to be this one. This is 1mm, so we'll start with the 1mm, and this will be for the front two ones. Let's check again. The camera isn't showing what I'm doing. I need to put it a bit up. Okay. Yeah, 0.9. We could use 0.9 though. Yeah. Let's use 0.9. So these are the new ones, but they're not exactly the same. What is the maximum I have with the new ones? It is not written. Oh, it is written. It's 1. This is 1. Okay, doesn't look like 1. Maybe I have a sturdy one here, which holds a bit better. So 0.9, it's this one. Up, this is 1. We don't need it anymore. A bit of overview. And I need to mark where it belongs. Up. So I can drill through. I have this. So ideally I would love for them to be in the solder. Something like this, yeah. Not right in the middle of the solder, that's on both sides. That seems fine. Then some, maybe 4 mounting holes are not too much. I have other ones with just 2 mounting holes. 2 mounting holes, but they're 2 plus 2. I think these 2 mounting holes don't go far enough inside. Yeah, it's just 1 millimeter, that won't be enough. I need 2 long mounting holes. What I can do is just snip off. No, I don't have other ones. I do have 2 plus 2 mounting holes. And oh, they look kind of. Are they long enough? Okay, they're not as long. So let's use these. And I will just cut off the 2 mounting holes on the back. The 2 mounting tabs on the back. I will only have 2 mounting tabs on the front. I hope this will still be enough. Because I'm afraid that I will drill. Yeah. If I do that, I will drill on a trace on the other side. So, how can I do? Maybe zooming will be enough. Here, if I put this device there, I would have 2 mounting holes on the front, and then 2 mounting holes on the back would go into traces. Although, would they? Yeah, they would drill into traces, which I don't want to go into. And on the other side, I won't have anything to solder. So let's just stick with 2 holes on the front. I'm breaking everything. Up. Right. Yeah. And yeah, I was afraid this is what would happen. I broke a drill bit again. At least it's in the wood. Okay, so now I have 2 drill holes. I hope this connector, I need to cut the leads on the back, the tabs on the back, else I won't be able to place the connector. One, 2. Am I able to put it inside? Yes, one side. Yes, the other side. Oh, and it's already a lot more rigid. Even just putting the connector inside feels a lot more sturdy. And I didn't even start soldering on it. Ah, that's a good start. Now I can solder on top, on bottom, and it will be a lot better. So let's switch on the soldering iron. I'm liking this idea. Yeah, here you see, I'm not even if it's not soldered, I'm already not afraid putting the connector up and then pulling on it. All the stress is now just on the 2 tabs. That helps a lot. So now we do a lot of soldering, micro soldering, so we can switch the camera and do everything under here. So you can see what I'm doing. Microscope. For the tabs, it's not too important, but for the parts on the back, it will become important. Up. Soldering iron is ready, and let's just solder the side. I'm not seeing what I'm doing. I should buy a trinocular, but I don't do on stream very often this fine pitch or this fine work. Okay, stick to the metal. Okay, it does a tiny bit. I wanted to stick a lot more up. I did move the connector. Okay, this looks sturdy, and I burned a tiny hole in my mats. So let's put something on the bottom, something like this, so I don't burn it, but then I'll lose the focus. Let me solder it out of the camera, then I'll show you in the end how it looks like. One, two, and then on the back now. Up. I want it to kind of flow inside, so it solders on the tabs. Try to flow inside. Okay, this is one. This is not useful. I can get rid of this solder excess. Up. Second one. Okay, this does it? Looks strong enough. Yeah. Let me remove the excess solder. Where is the tweezer? With solder braid. Up. Up. Let's clean it a tiny bit. Some alcohol and swab. It doesn't look connected on this side. We'll have a look at the microscope. Don't take this one anymore. You need to focus. Yeah, it doesn't look connected. Tiny bit, but not a lot on one side, but not on the other. On the front it looks fine. The front it holds quite well, but I also want it to hold on the bottom. There is a tiny bit of connection, but not enough. Let's add more. Okay, this looks a tiny bit better. Up. Switch the camera. You see, it is not perfectly connected. I would right there, it's not perfectly connected. So this is the tab. It is a bit soldered on it. I hope that this will solder on it, but it doesn't. And here there's a tiny bit more. There's the tab. It is connected, but this is sturdy enough, I think. On the front, it is rigidly connected. And let me just plug and unplug, because I want to do a stress test. So I will just plug and unplug all the time, a couple of times, and if it looks solid, yeah, plugging, unplugging, plugging, unplugging, a lot more solid. Even with just 2 tabs already. Yeah, I'm not afraid of this anymore. I will still add some mitigation on the case so we don't wiggle too much, because it won't last the wiggling a lot, but the plugging and unplugging is fine. And now comes the hard part, soldering the wires on the bottom. So we don't need this, we need a lot of flux, and you won't be able to see, it won't be too terrific for you to see. You'll still see a bit, but yeah, I don't have the right camera and the right angle for that. Yeah. Can you see something? Yeah, you can see something. Let's switch the camera. Now I'll solder. It's not perfect. Can I? No, I can't move. I can't have a better angle. Yep, I need a trinocular. So let's solder. This is, so the only pad which is remaining, this is VCC or ground. And leftmost is VCC. Yeah, it's V-bus. This is the only one remaining pad. It's easy to solder on it. Okay, one pad is soldered. What you can see here with the test lead, this here there's a via. The trace is broken and you don't see it, but actually the via still seems okay. This is ground. So with the multimeter, there's just this ground against, yeah, here against ground. So yeah, the via is not damaged. I can still reuse it. That's okay. Now we will use this tiny wire. This teeny tiny wire. This is just, I call it magnet wire. I think it's called enamel coated copper wire. So let's burn the coating, enamel coating, enamel. I don't know exactly the word. I just call it magnet wire because it's often used in magnets, coils, and so on. Okay. I remove the coating, which is insulating. So when you roll the wire, the wire, it doesn't connect to it. And I need to put a tiny bit of solder on the pins already, else I won't be able to solder on them. There's enough flux still, that's okay. And now I'm using a bit finer tip and not this hugely tipped. Yeah, tiny bit of solder. Ah. Wrong connection. Okay. 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 Tiny bit of solder. And because we used this when we did solder, we removed all the flux. We just re-add some flux. It's a lot of flux, but Meh. It's fine. We can clean it afterwards. Now I need to solder this wire. This is I think it's 0.1 millimeter wire. So what you're seeing is 0.1 millimeter. And I want to kind of tilt it, so when I solder the pad and the trace at the same time, because you can't solder one after the other, since the wire is so small that when you solder the other one up, the other parts, the other end, it will desolder the first one. We need to solder both sides at once. It seems soldered. It is holding. Let's cut it. So to cut, just press hard on it and wiggle slightly. And this is how you create a trace when it's broken. Now let's test if the trace, if the connection is there. It is a bit tiny on the junction of the pad, but I think it is there. Let's test it. Between here and the pad. Yeah, makes beep. Yep. So here we have our first connection. That was faster than expected. Let's make the other one up. Again, remove the coating. Of the wire. Okay, it's removed. You in the way. So you can see that. Can you? Yeah, you can see that part of the wire has coating, the other one doesn't. The tip doesn't have the coating anymore. And the next trace will be here. Oh, there's a huge solder blob on this thing. Up. Wire, don't bend up, bend down. Okay. Seems the second trace has been soldered. That was fast. Let's cut it. Up. Let's test it out and beep it. From the pad, yeah. I'm just touching the copper on on this, and it is connected. There is a bit of resistance, but there won't be a lot of current going through. This is data, I think, V-bus. Then we have data minus and then data plus. This is data plus. Since data, there won't be anything. And here, the ID pin, I don't know why. When you have this kind of device, you don't need the ID pin. I don't know. So this is the ID pin. Generally, this is for off-the-go stuff, and for off-the-go things and things like that. There's nothing on the go here, so I don't know what this is for. Where do they connect this? Just to a termination resistor? Maybe that this is a debug pin? I don't really know. There is still a trace, so we will have to solder it. And this trace is a bit larger. a little bit larger. The gap is larger, so the wire will be a bit longer. Oh, where's the wire? Nah. Come on. Could add like, yeah, probably need to solder it on 2 points. I'm not sure we'll be able to solder at one time. And I need to switch hands because the soldering tip will come from the from the right side, which for you is the top. This damn tweezers. I do have remote. Let me use it. I don't know if it's too big. I do have remote action tweezers. Maybe they will help, so I don't need to hold it all the time. Yeah. Here. I need to solder between here and here. Without shorting on the other side. Okay, let's try that. Soldering iron. Board, stop moving. I will have to tape you down. Okay, that's one side. I think it is also connected on the other side. Let's wiggle on it. Soldering iron up. I need both hands. Is it connected on the other side? Oh. Trace is a bit fragile. Yeah, it is connected. Let's test again with the multimeter. Yep. Maybe I was beeping on the wire. Let's remove the wire. And I'll probably add some solder mask on top of it. But I only have green solder mask. Still, I probably will add solder mask so nothing bridges, and it kind of, this trace is very fragile. Yeah, I will add some solder mask afterwards. That's not what I wanted. Probe 1. Yeah, it's fine. And now this is ground. We can sheet and ground the shield, and what we would like to do is have so this is 0.1 millimeter wire. Here we have a larger trace, a ground trace. It would be nice to have 0.2 millimeter wire. I do have that. Twice as thick. It's also a bit more rigid. Is it already prepared? Yeah, but not long enough. Let's again remove the coating. Okay, coating removed. And here, I think too, I will have to solder at 2 points. And I don't want to come from the right side because I'm afraid to touch on one of the previously soldered parts and then on-soldering it, which is just more work and more pain. So let's solder it from this side. But I'm not sure we'll be able to do that. Yeah, I'll have to come from this side. Okay, right hand it is. Do we have enough flux? I think so. Okay, that's one. No, that's not. I was too fast. No, don't move the other. Okay, that's one pad. Let's use the small tweezers, a more precise one. And oh, there's not a lot of solder on there. I need to add some solder. And yeah, doesn't look thick, a lot thicker, but it is 0.2 millimeter wire. Okay. Ah, damn it. This is because I didn't hold the thing. And this microscope I have has such a ridiculous working distance. It's hard doing anything on it. But for most work it works. I'm not using it too often, and for most things it's enough. Up. Board. I'll tape the board. So let's put this here and I'll tape the board down. Where is my tape? Here. Up. Okay. Now it doesn't move. That's gave me a tiny bit of help. Okay, both are here. Both sides seem connected. Let's cut it. Then probe it. Yeah, I see that this is thicker wire because it's harder to cut. Okay. Now let's probe the ground connection. It is shorting. Is it too shorting to the other side? No, damn it. It is shorting. Okay. Ah, damn it. Will I be able? Wait. Maybe it is connected to ground. No, it shouldn't be. Here it shouldn't be. Okay. Oh, it is connected to ground. Here I don't think the cable is... No, this is not shorting it, but if I probe here, it is shorting. So it is connected to ground, so my soldering was fine. Yeah. The soldering was fine. Okay, ground seems connected. Ground here, yeah. I don't know why. So this is probably just... But why didn't they short it here? I have no idea. But the short is not coming from here, we tested it. So, let's clean it gently to see if it looks fine. Gently, because we don't want to destroy just the work we did. Come on, you. This burnt part. Go away. I think it's solder mask. I don't know why it looks so burnt. So, let's give the alcohol a chance to evaporate. Or is this all solder flux on the bottom of the connector? Ooh. The one on the complete left doesn't look ideal. Maybe I should add a tiny bit of solder. No, I won't. I'll just break it. There is a connection though. Test it again. It's very light. Yeah, but there is a connection. What's all this crust? So this is burned. Oh, this is FR4. Up. Clean it again. Some alcohol. Yeah, the rest, what we see is just damage from the board. So, now we can test the USB connector. So, journal control. Now, journal control -F. Can show it to you. Laptop or mouse, it's this side. So here you see all my laptop events, and is my USB cable long enough? I don't reach. Yeah, so here's my USB cable, and if I connect it, you should see TTY USB 2, I think. And there's none. Why is there no? It does get power. I see the 2 power LEDs. Oh, there it is. It was there. It was just that it is there. Descriptor read error. Let's try it again. Yeah, it is there. So this works. So this is fixed. Now I will add some solder mask to protect the wires against shorting and to have it and protect the traces against getting stripped off. I just need to get my chemicals up. So where is my solder mask? Is this solder mask? This is solder mask. Here I have a tube of green solder mask, and I just need a tiny... It is also I hope it's still okay, but you cannot buy it in smaller quantities. You need always such a big thing. Yep. So, yeah, it looks old also. Let's try to mix it a bit. Seems like all the solvent has been evaporated. Ah, no, I think it's okay. It is very thick. Let me switch the camera so you can have a look here. This is the solder mask, and yeah, it seems I don't remember that it was so thick. Try to mix the solvent. There was a tiny bit of like an oily layer on top of it. Okay, we don't need so much. We don't need it all. We just need a tiny blob. Garbage up here. Tiny blob. And I don't have red solder mask, although this board is red. I don't have any red solder mask. Up. This looks a lot better. So, green solder mask. There we have it. I have some on my finger. Okay. Let's switch microscope. And you see, we just really need a tiny amount. Oof, it's already too much. And let's use another pick to try to spread it around in a thin layer. Yeah, also on top of the connectors, why not? I know why not, because then I cannot probe them. Let's try to clean it from the top of the connector. Go away. No, doesn't want to. Yeah, I don't care. I don't think I will repair it at another time. So, and solder mask is cured with UV. So let me get my UV torch and try to cure it. Not sure if you see the faint glow, but this is UV. And you already see it hardening. The texture isn't the same. If we poke it, I should already see that it is a bit harder to poke. See, it's not gooey anymore. It is robust. It's not completely soldered, completely dry, but almost. Let's try the cable again. Let's see if we still have USB 2. If I did break something. Okay, I broke something. That's not good. Come on. What did I break? It does receive power, so it's really just a teeny tiny line here, which was, yeah, that's really a teeny tiny line. But now we have a tiny bit of solder mask, so we can use it for the robustness. I think it's this this one is not connected anymore. So let's scrape a bit and add a bit of solder. I couldn't verify reading the multimeter, but really think it's this one. Now it's connected. Please work. No, it wasn't this one. The other one? This one? These are D plus and D minus, so it's either or. But this looks fine. This goes here, we could scrape a tiny bit here. Test it. Why does this? Is this connected here? No. That would be weird. A data line connected on a capacitor? I don't think that's... Oh, it is. Okay. So this is connected, and this goes probably to... I don't know where this one goes. So this goes here. Then it goes somewhere around here. It should be somewhere on the FTDI. So here. This here. Now you're on the way. This is data plus, so the other one should be data minus. It is connected. Okay, not very reliably. Maybe the solder is not good enough. Now the solder is good enough. Now there should be no issues. Okay, now it works. Yeah, seems to be that this was the case. Good that we soldered it in the beginning. Let's try disconnect. Reconnect, yeah. That seems to be the case. This is fixed. It looks okay. So now we will add the second layer of mitigation, because this works, but my second layer of mitigation is this glue gun. It needs to heat up, so let it heat up. Let's get the case. This is the case. Let's put it back in the case. Did I break a tab on it? Oh, I didn't. One connector. I hope the USB is still reachable. Yes, it is reachable. Screws. Screwdriver is here. That was my another screw. Not the one I want. One. Two, and now I need a USB cable. We can test it again what's in the case. It should still work, yeah. The plug is still reachable. Let me get a USB cable. Micro USB with data. Micro USB, they are all white. Let me get a black one so it fits the case. That's power only. USB micro B2. Let's up my box of micro USB cables. No shield. But yeah. Okay, if there's no shield, the shield is used. Ah, but no shield, there's also no shield on the cable. Ah, it's not a problem. That looks fine. So I'll just get a cable. Let's connect it to the USB port on this side. Up. And now, are you still seeing the other camera? Weird. I don't know, I think I've changed it. Let's try to connect to see if it still works. This way around. And please work. Yes, it works. And the glue gun is probably not warm enough. No, still have to wait. I can close the case though. Up. Let's unplug this USB cable. Last screw. Okay. Glue gun, are you warm? Is this still on? No. Getting there also. Yeah, I need a new stick. Yeah, it is. It is warm enough. But I need a new black stick of glue. And my second layer of mitigation is not letting the user plug and unplug the cable. So we will glue it in place. I didn't need a new stick. And let it cool down. I think it should cool down fast because it's on a rigid metal body. Let's wiggle it. Up. Yeah, I'm scratching the anodized aluminium. Okay. Now it's in place. You can't unplug it anymore. And does it still work? Let's plug it in. Yes, it still works. Second layer of mitigation. So now he won't lose a cable. That's good. And he won't be able to break it. And normally, well, it is plugged in. Why doesn't it make any color? This should make some lights and some color. It should work. Let's try. Let me try to recognize to see if it is recognized by the DMX controller. Up, up. I never know why it makes lights and so on. Okay, VirtualBox is starting. Let me switch to the screen. No, that's not it. Full screen. This one. Okay. Yep. So I do have still my virtual machine with Windows on it. It's a test version of Windows. And it is slow. It is super slow. So let's connect here this DMX Pro. Let's look at the manager. I did also upgrade the firmware. It seems that last year there was an upgrade on the firmware. I've added it, and surprisingly, what is the firmware? No, the version detection. So they didn't fix. They fixed the firmware, but they didn't up the version number. So when you ask for the version number through the DMX through the USB interface, it reports the previous one. Happens. No, I don't want to restore. Yes, I don't care. I'm not using the Google API. So here looking for serial, DMX description, device found one. It's kind of slow, but it is working. Select device, here's the device. It starts talking to it. Yeah, but since I got the serial number, it should be fine. Device in error. Okay, that doesn't sound nice. No, okay. Device in error mode. Reset device. So the reset device is a firmware. Unable to write firmware. What? Okay, so the wires I've soldered are not good enough. That's not good. So it's enough just to connect, but not to. Maybe the cable was not good enough. Yeah, I use the cable without shield, but that shouldn't be too much of a problem. Okay, let's try again. Device in error mode, select the firmware. Don't have the firmware anymore, do I? I think I do. Here. This one. Choose desktop 4. Update firmware. Please use correct. What? Invalid firmware file? What the hell? I have no idea why it should. What it tells. Okay. Come on. Desktop. I did flash this firmware before. Why are you making such a fuss? What is going on? Okay, I didn't test it before so thoroughly. But I mean, it's able to find the device. Let's disconnect and reconnect it. And probably what the arrow meant. Did they break something? Find devices. Hey. Ah, the manager that died. Okay. Very sturdy software. Very sturdy. Yeah. Device in error mode. Okay, that's not an issue. Status. It's this one. Reset. Unable to write firmware. Okay, the USB interface doesn't work well. Probably getting a lot of packet errors. Is it because of the cable or is it because of my soldering? Let's try one after the other. Let's try with another cable. So I have to remove the glue. Here, we remove the glue. Let's try with a more decent cable. Here. Oh yeah, it was because of the cable. Now it's blinking. You don't see it because it's on my desktop, but now it is blinking white like it should be. So the cable was just crap. Now find devices. Why is it so slow? Ah. Let me show you. I already found one. Then you can populate the other devices. Come on. Okay, died again. Super software. Ah, now it's connected. See, I flashed 4.8, so the cable was wrong. I flashed 4.18 and it is showing 4.15. So yeah, they forgot to bump up the software. So looks professional, but you've seen we've managed to crash it twice. The software version is not correct, so they still could have better quality check. But we know that this cable is faulty, so what do we do with faulty cables? We bin them. We don't try to fix them. So bench here. Up in the bin. And now let's use another cable. I do have enough of these micro USB cables. It shouldn't be an issue. No shield, no. Let's try a short one. It is rather short. It's a bit too short. Let's use this one. Up. I hope this is better. I'll make a video about USB cables. Don't worry. How to test them. I knew that the previous cable wasn't good. It was marked as not good. But I hoped it was good enough. It wasn't good enough. So let's connect. And it should blink white, but it doesn't blink white. What is happening? Maybe it shouldn't blink. No, it should blink white. Come on. Is my USB extension just broken? So if I connect it with a very good cable, yeah, it should blink white. Let's connect it here. I know that this cable is good. but it doesn't blink white. This is very weird. With one cable, when I plug it, it blinks white. With the other, it doesn't. I have no idea what's going on. Yet another cable. I'm not lacking USB cables, so that's fine. USB, and it's probably good that I fix the cable. Okay, this one blinks white. It has no shield, but it blinks white. I'll give this cable a go. It's long, but now let's try if it works again. Here, find devices. Come on, I'll make it crash again, right? Yes, I know how to make the software crash, definitely. Full screen. Just press on find devices where it's looking and refresh the bar, and it's completely lost. I mean, they're in the business it's a long time. They haven't found this bug at any point? Come on. It's amateurish. Charging a lot of money for this small device. So, yeah, this USB cable works. I don't know what the other one don't work. This one works. So we'll stick with this one. Now I need the stick, which I have here. Okay, the glue doesn't look nice at all, but I think it holds up. Up. Okay. Let's try it again. Up. Yes, I see the USB here, and it's connected. Find devices. Yeah, you see in this state when it's turning, it's doing nothing. Reload. Ah, reload works. Maybe it just takes time. And yeah, we see the devices here. And yeah, no, I crashed it. You see? The DMX manager is crashed. It's dead. Okay, they never tested this software. I don't believe that when you click find devices and there's an issue that they never encountered it. It's super old software. You see how the layout is done. Let's check the information. Is there any standalone find device close? Okay, can you tell me here? The software is from 2015. In 6 years they haven't been able to find this software or to fix it. Bad. Okay, but it works. The device is now really completely fixed and it blinks white. So yeah, it was good to have broke it. It was broken. I fixed it. I broke it. I refixed it, and it's now fine. And with that, the job is done. And I can give this USB DMX thing again. And yep. So with that, the stream is finished. And now I know that it is working because I leave. Come on, I did it until the end. Bench. screen, no, bench. Okay, with that the stream is finished and the repair is complete. So yeah, enjoy the rest of the day.